In this lecture, we are going to understand the coding of an encoder-decoder transformer with multi-head attention. First, we need to import the PyTorch library, and then we import the neural network functionalities that we will use. Next, we will define our encoder-decoder class. There are three types of attention that we have learned so far: self-attention, masked self-attention, and encoder-decoder attention. In this example, we will focus on encoder-decoder attention. To start, we inherit from the neural network model for our attention class. Then we define the constructor, which initializes the weights for the query key and value. Here we also specify the row and column dimensions for the matrices. Next, we override the forward method of the neural network model. This method allows us to pass in masks if needed. To calculate the attention, we first create the query by multiplying the query encoding with its corresponding weight matrix. We do the same for the key and value matrices. Then, we multiply the query by the transpose of the key and divide the result by the square root of the key's dimension. If a mask is provided, we apply it as a scaled assignment. The mask ensures that certain positions in the sequence are ignored during attention calculation. Any value that is masked is initialized to -infinity, while other positions remain unaffected. After applying the mask, we calculate the attention scores using the softmax function along the specified dimension. Finally, we multiply these scores by the value matrix to get the final attention output. This process computes the decoder's attention scores while respecting the mask, which is particularly important for generating sequences step by step. In summary, this is how we calculate attention in a decoder transformer using masked attention. The mask prevents the model from looking at future tokens while generating the current output. I hope this explanation clarifies how attention scores are computed in the decoder.